action-packed evening today for you. I'm going to do a bit of overview of what we'll be doing this evening, and I'll be kicking off then with the first session myself. And then Siobhan will be coming in. We'll be doing every second talk more or less like last week. You can see a few changes here in our course web from last week. Something new here is our assignment. This assignment we'll be looking at a little bit later on. It's your first specification, and we'll be spending some time discussing it in the next hour or so. Last week's session you will see here. It's as we delivered it, except this time you will have the audio available. So you have audio and video for each of the talks that we gave last week, and of course the lab here, as you might have concluded it last week. Okay, this week's session, I'll just dip into it briefly. It doesn't have any video yet because we're recording it. We're reviewing the Java programming language in some detail. Accelerated though, so we're covering substantial body of the language today with some more work next week. I'll be introducing the language in general, its background and purpose and some of its history. Siobhan will be then taking you on a tour of the basic syntax of the language. I'll be coming back in to talk about classes, one of the key building blocks. Siobhan will cover control statements. If we have time, we might skip this if we're running a little bit short of time. And I'll conclude with some general topics on object orientation in general and some of the language we'd have encountered as we proceed through the session today. We have our chat room open as usual. It's the chat room, as you can see on your right here. We also have the Gitter chat room still available. That's through this button here. I sent out a note earlier today saying we are opening yet another chat room, 3 chat rooms now. This other one is a private chat room. The one I'm showing you here is public. That is, anybody can join it, and it's also anybody can read it even if they're not part of the room itself. That's okay for just getting going, but we might like to keep our ongoing interactions a little bit more private. So you should have received an email about that, and as soon as you reply to the email, I'll invite you into the room. We won't use that room until tomorrow, and we'll still use the public one if people are out. I understand there's still some issues around Sun Life access to Gitter, so we will be keeping the Adobe Connect chat room going for the moment until those are resolved, and we'll keep it going permanently if they aren't. Okay, that's us to get started. As we did last week, we go through our talks. We pause for about 5 minutes between each talk. You can engage with us on the chat room there if you like. And then after 5 minutes, we'll resume and we keep that cadence going. Okay, I'm going to start now with the first session. We are going to review the Java programming language, and I'm going to give you some background and some early indications of the kind of structures that are used in the language, and we'll proceed with that for the morning, the afternoon. This is our general plan. Again, we're assuming you have experience in computing and programming in your background, maybe not Java. If you have considerable Java background, then a lot of this will be fairly routine to you. We'll go through it reasonably quickly, so hopefully it won't be too onerous. If you have another programming language, we're moving reasonably quickly through it, but hopefully you'll be able to tie in your own knowledge to the concepts we present here. If you've done Java at some time in the past, but not a lot since, then this is probably particularly useful as a refresher. We're not going to be covering all the topics I'm showing you here today. We're going to look at the overview, which I'm doing now. We're going to look at the basic syntax and arrays, which Siobhan will be doing. We'll be looking at classes, control statements, and then we'll probably stop at that point. Inheritance and collections is a topic for next week, and moving further into exceptions and streams, they'll appear intermittently in later weeks, perhaps not immediately. Okay, let's have a look at what we're doing then just for the next 20 minutes or so. History of the language, get a view of where it fits. the basic syntax, basic structure of the language itself, including how we introduce variables and objects and naming conventions, and then arrays. Let's start with some of the history. Siobhan took me on a tour of the family trees last week. They are fairly extensive, and of course, Java is a key part of the modern evolution of programming languages. Java appearing in 1995. However, its origins go back quite a few years previously to 1991, and the original code name for Java was Oak. It came out of Sun Microsystems, and Sun, company gone now, was the shepherd of the language for its first 15 years at least. The language itself, interesting enough, was not intended for the use it became famous for in subsequent years, that is, as a server-side language for web and enterprise applications. Its initial focus was consumer electronics. I think the original application was set-top boxes, a prototype Sun product at the time. That's curious because it arrived back in consumer electronics many years later with the adoption of Java in the Android platform. But there had been quite a number of years when Java was maturing elsewhere in its history. It does have a footprint in embedded development. That's less so now, I think. In recent years, it's been superseded by other variants, either of Java, JavaScript, or more specialized embedded languages. However, you will find it on some older equipment. The language itself is designed to be portable. And this was an early differentiator of this language from other languages, particularly languages it was closely related to. Java itself could be considered a direct descendant of C++, and C++, of course, still going strong. Java shares a lot of its heritage from C++ constructs, but what it didn't take from C++ was portability, and the early decision to go for a virtual machine that was ported to different architectures was a key differentiator of the language. So the Java compiler always generates machine-independent class files, which are then compiled or interpreted, or sometimes both, down via JVM to run on specific platforms. Another key differentiator from C++ is memory management approach in Java, which adopts a garbage collected approach. This means that our objects, as they are created, are automatically destroyed. That is, there is a process running periodically in the background on our JVM, which is tracking, marking, and sweeping out the door any objects that are unused. This is probably the majority approach now of the languages we were reviewing last week. Certainly Groovy, Kotlin, to a certain extent Swift, all are garbage collected languages. Also Go is garbage collected from Microsoft. But C++ and C remain noticeably uncollected languages. And they're unlikely to be garbage collected in the foreseeable future. There is some performance implication with garbage collection, and the languages that require hard real-time requirements, which may include C and C++, often can't forego that requirement. We have a variety of versions, and depending on your organization, you may be on an older version. That's often for very sound reasons, to do with stability and compatibility. We're going to be focusing on most of the features as arrived in Java 7, but we will be revisiting in subsequent talks Java 8 and 9. So for today, we're sticking with version 7 more or less. The language itself was very stable for many years, a bit like JavaScript in a way, in that innovation was very slow, but has picked up in recent years, and from 7 to 9 has seen some significant new innovations. So structure of the language itself, if we look at briefly, it's fairly conventional in terms of how we rules for identifying variables and types. We use letters, dollar signs are possible, underscores, and so on. There's a range of reserved words which we have to avoid, like in most languages, and our identifiers can't contain white spaces. They can be any length we like. These are typical examples of what we can and cannot use. Nothing surprising there, and it's mostly comparable to language you're already familiar with. The structure of a statement, particularly when we're invoking methods on objects, we have names for different parts of these lexical structure here. We sometimes talk about a message receiver, a separator, a message, an argument, and a statement ending or a terminator. Here we're just invoking a method on an object, invoking a function on an object, you might think of it. And the notion of messages and message receivers and message context is it's a kind of language that appears in OO thinking generally, although perhaps not as widely used as it once was. Here's another fragment. Again, it will be largely familiar to you from other languages. Variable type comes first, then the variable names follow, and we may optionally provide some initialization of the variables themselves. So in this example here, this is the variable name, and this is the type preceding the name. We'll be seeing later on in some other languages slight variations on that. Particularly, we'll see some variations in the use of Kotlin, and we've already seen how Swift does it slightly differently. This here is an example of initializer. We're initializing a variable, via simple assignment statement. And of course, down here, we seem to be doing something else. We seem to be creating an object, and that object is now made available to us in this variable here. Semicolon is a valid empty expression, and if you're not careful, the empty expression can come to bite you occasionally. Here, a common error for people new to Java would be to use the semicolon in the wrong place. That is a terminator here, which means that this loop does execute, but doesn't print out the value I 3 times. It does nothing, and the printout statement occurs just once subsequently. If you're coming to this language from Python, this will look really weird because we have indentation here apparently expressing our intention. But indentation is entirely ignored by the Java compiler and system and has no impact on the execution. Okay, comments, as you would expect, they are inherited from C++, single line or multi-line comments. And there's a special form of commenting for documentation called javadoc comments. And if you follow certain rules, which we're showing you here, then the javadoc tool bundled with the environment can generate documentation in web form. So it is possible for us to have a comment something like this, and this is in our source code, remember? And if we invoke the appropriate processors, the javadoc tool itself, then we're expecting this to produce a web page, which will give us something that's readable and browsable in this context. So this will produce this to a certain extent. We might be making use of that in our labs, although it's less important for the scale of the applications we're building. You'll probably be familiar with the structure as generated. If you've looked at any of the reference material we mentioned last week, you might have stumbled across pages that look a bit like this, which are the javadoc output of some of the standard libraries. Java does support literals, of course, when we want to introduce constants of given values. Here we're declaring 2 strings. And of course, there's 2 slightly different forms. In the first one, we are declaring 2 strings, 1 and 2, and we're just introducing simple string literals directly into the program. This format is identical to the second one here. And this one, we're creating what looks like an object. We haven't looked at object creation yet, but effectively this notation here is a shorthand for this. So they're both identical. Okay, so that's just a brief overview of the structure of the language. I'm going to take a few minutes break here now. We can chat a little bit if you like, and then we'll come back in a few minutes to look at the basic structure of the language itself and to go through how arrays are implemented. So see you in just a few minutes.